Well, this will be a short presentation. I'm going to go over a little of what we've done so far, and we have two full presentations here, so this will be quick and a lot of information, and everyone's stomachs are probably starting to grumble for lunch, so I'll go quick. But we're going to talk about the use of these data, these push-button derived PED volume data, in building a bigger data fusion model so we can forecast out estimates of pedestrian volume in places we don't have data. And then also just a little teaser on the work that we've just begun to evaluate a third-party data platform's PED volume estimates. And that's the Replica platform, which I know Portland Metro's had some experience with. So in time, hopefully we can chat more about what we got going on and how we're doing it. But I'll share some here. So similar motivations as were shared for the work that Alex and I presented on the last presentation. So, we did some work a couple of years ago now where trying to understand the relationship between traffic safety and social equity. A number of different analyses were performed in that work, which I can share the link to that full technical report at some point. But one of the analysis that was done was sort of a zonal analysis of where pedestrian injury occurs. We did this at the census tract level, combining measures of the census tract around, traffic density, other built environmental factors, and then sociodemographic variables, income and race being ones that were predictive of where pedestrian injuries occur, even after controlling those traffic exposure and built environmental variables. We got all the way to using those models in a predictive fashion with an example here for the Salem metro areas showing where the highest and least likelihood of pedestrian injuries would occur at the tract level. Well, that's interesting on sort of a very 10,000-foot view, but when you're trying to put placements of interventions, knowing a whole census tract isn't all that useful. So the work that we did a few years ago was transitioned into a second phase where we're building intersection and segment level predictive crash models to help with network screening, before and after studies, and a few other applications. In order to get there, though, we need exposure measures for pedestrians. And so we are taking these push button data and integrating them with some of the other data we've put together for the safety performance work and see how things work. So we're at the really just a couple weeks into that data fusion estimation work. So I'll share a little teaser of that. And then thirdly, and again, this could be a whole presentation on its own, I just want to talk about and let folks know that we are evaluating against those push buttons estimates from Replica. Let's see if I got some more on Replica. I'll talk more about how Replica does their thing for folks who are uninitiated. So this is a little of the workflow for putting the data together for our safety performance function project and data that will also be used in some of the data fusion work. So, we're taking as a base network a version of the OSM that has some volumes on it from INRIX, which is the analytics company, transportation analytics company that does our speed data. We're using that. We're conflating with HPMS data. Those are sort of the data of record for where our volumes are. Putting the speed measures on, again, from INRIX onto those data, and then building out intersection inventory, road segment inventory with other variables about number of lanes, speed limits, medians, other important measures that we'd want to include in our safety analysis. So we're just now getting into the data development stages 5 and 6 here in this chart, where we're adding information about transit, sidewalks, pedestrian crossings, because we don't have that yet. But we've already, with the data we've had available statewide, or at least in the urban areas, the sort of purview of the safety analytic project is the 66 urban areas in the state. Since about 90% of pedestrian injuries occur in urban areas, we kept it to just urban areas as our geography. This just kind of goes into a little more detail of all of what we're combining. I mentioned a bunch of these, of course, the crash data. We're also bringing in smart location data. They have a lot of good information in the EPA's SLD data around accessibility and the sort of the 5 or 6 or whatever 7 Ds, density, diversity, those sorts of things that are useful proxies for pedestrian activity, which is what we've used so far. Ultimately, we'll be conflating and joining information about pedestrian infrastructure data on top of these data, at least where those data are available before we do the big CFEC multimodal inventory process. I have a dashboard I can share. You can peruse some of these data. The intersections for Portland metro area will render, the segments won't. I still need to fix that. So for Portland area folks, you'll have to be happy looking at just intersection data. So data fusion, what's data fusion? I feel like this is like an overly cool term for just some of what were initially like decades ago, the preliminary kind of travel demand models, where you're just taking a count of traffic like at an intersection on a segment, and then as a function of other in sort of environmental built environment variables, predicting the volume at that site. And so data fusion, just a fancy way of like saying we're predicting the traffic count as a function of a bunch of other variables that we have data on across the network. And so a picture here from a project we did out in Bend, deploying these methods. You got your traffic counts up here. We got measures of access to jobs and network centrality, other network level features, information about what type of segment it is, how many lanes, what kind of functional classification. We combine that all. We use statistical model approaches like regression, but we've also had pretty good success with machine learning techniques too. So that's sort of what we're talking about when we're talking about data fusion. One of the issues with pedestrian modeling is that we don't have a lot of data. Alex mentioned this about calibrating our models. So currently we have about 600 or 700 of these sites around the state at signals. We have short duration counts that we haven't totally processed yet. And then we do have permanent count sites, and we've had them for years on off-street paths around the state. And we took some time many years ago to integrate those data into a single database. The problem with those off-street paths is that the traffic patterns in those locations are not always the best to use for like traffic factoring, short duration counts on street facilities, because they're just totally different patterns where you have a lot more recreational users on those facilities. And that's another really great thing about these push button data, that they're on street locations. So we're combining those data about the intersections, what the vehicle volume is, what are the INRIX operational speeds, what kind of intersection is it, a 3-leg, 4-leg? We have other measures that come from a zonal, level for sure, from census block groups, from the smart location database that we're putting on top of those points, if they're intersections or segments. For the segment level models, and then trying to estimate and figure out what the relationship is with all of those variables and the pedestrian volume. So here's just like a very preliminary set of models where we're looking at the effect of all of these measures on the left and the relationship with pedestrian volume. So the higher, this one has stuck out is somewhat strange. I think we'll probably have some unobserved variable bias here, but the more vehicle volume, the more we'd expect the pedestrian volume to be. I think we're missing something there that we're trying to account for with like this interchange proximity variable, which is going in the right direction, but a more reasonable sign with the max speed. The higher the speed, the less the ped volume. And so maybe if there's a lot of cars, but they're all moving very slow, maybe we would expect more pedestrian volume. Again, these are preliminary models, so as we dig into this, we'll see. Intersection characteristics, so 4-leg versus 3-leg, interchanges, a lot less volume expected. And then some of the sociodemographic information here, we have the higher the volume, the higher the income, at least at the block group level, at that intersection, the less pedestrian volume. More employment, this is a spurious one too. It's significant, but it's telling us that total volume, pedestrian volume is going to be less in higher employment areas. We may need to specify this feature differently, maybe look at density, maybe look at different types of employment. Population looks like it's in the right direction, more population, more people walking in that location. There's a measure we have in SLD called the National Walkability Index. This isn't a measure of like safety or anything. It's just a measure of like kind of diversity of uses. There's some transit mixed in there too. So the higher the walkability, the higher the traffic volume for PEDs. To your question, Ray, about transit stop proximity, we're just looking at the total number of stops within 50 meters here, more pedestrian volumes. We have measures from the census around journey to work. So that the more people taking transit, the more, at least for work, the more people we'd expect walking at that intersection. Journey to work for walk trips, not significant, not in the direction we'd expect. And then a couple other fun data points that we're putting in. So, as a DOT, and this goes for all the local agencies, we have free access to Strava data. Strava data has been useful for predicting where bike activity happens. It's bias data. We know it's older men, for at least the biking, probably higher income, taking mostly recreational trips. So we're using the walk, jog, and run trips and seeing if they're going to be useful. They do add a little bit of explanatory power compared, using the R squared as a metric there. We're using the total Strava trip count here and then the commute count trip here. And so you see there's a little degradation in model performance using that measure variation or explanatory power when we use the commute trips, which is too bad. So we go back to using the Strava trips here in some of these models, adding a couple different measures for like if there's an arterial entering that segment or entering that intersection. And then so our first blush here at looking at the replica data, we use those as just an input feature here in these data fusion models. We lose some observations because they didn't, for some reason, give us their estimates at every signalized intersection we asked for, but it does boost the explanatory power. So that's a little of where we're at with data fusion. The idea then is to take this model, we apply it to every intersection that we have in all the urban areas for volume estimates. But we'll do a lot more work testing using cross-validation, and which is a much better way to understand the accuracy of your model and stuff that we can share in the future. So real quick, don't have to tell probably a lot of the Metro folks about what Replica is, because I know you guys have had experience, but Replica is a big, one of these private data firms that basically buys every piece of information about you and puts it together to build a really cool activity-based model. They have types of data on us that I think most of us would love to have, although I question whether or not our privacy is being violated with some of the data out there. It's open, it's available for purchase. There's no laws against it, so they're not breaking any rules, but it's unclear if that's going to be the regulatory atmosphere going forward. However, this is the way where things are. This is a little of their data flow. And what we're looking to do is use one of our previous data quality rubrics to assess what the quality of data is that they're providing for pedestrian volume estimates. So we'll look at accuracy, completeness, things like accessibility, how easy it is to get the data for any application, whether it's travel demand modeling, safety analysis, whatever. We'll try to report out as best we can on all of these metrics. I don't have results yet. They'll be coming hopefully here in the next few months. Would love to share out with groups that have any interest in this and let you know how it goes. So that's it for me on data fusion and the replica evaluation. I'm happy to take questions and wrap it up.
All right, thanks, Josh.